All right, we've made it to the end of chapter 4. This is 4-6, formalizing relations and functions. So, some definitions. A relation is a pairing of numbers from two sets. Those sets are referred to as the domain and the range. So those are probably new words, domain and range. Domain is the set of all possible x values for a function. Range is the set of all possible y values for the function. So the domain is the x's, the range is the y's. All right, so identify the domain and range of each relation, represent the relation with a mapping diagram. Is the relation a function? So we've talked about what a function is. So in a mapping diagram, what happens is you have two, it's typically ovals, right? In the first oval, you write your domain, right? The domain is all of the possible x values. So in an ordered pair, remember, domain is the first one. So we'd have 4, 5, 7, and 4. And you write them typically in order. So 4, 5, 7. If they repeat, you do not write them a second time. You only write them once. So the x's being used are 4, 5, and 7. So then, in the right oval, you would write your range. So the range is the y's that are being used. So here, 1, 2, 5, and 0. Again, it's a list of the y's being used, typically in order. So 0, 1, 2, 5. Then what you do is you draw them, a line, from the x to the y. So like 4, 1 here, we would go from 4 to 1. 5, 2 goes from 5 to 2. 7, 5 goes from 7 to 5. And 4, 0 goes from 4 to 0. So then this is an easy way to tell if something is a function or not. So remember, we've talked, a function means every x has exactly one y. So looking here, I can see this x value of 4 has 2 lines coming out of it, so it has 2 y's, so this is not a function. Is this a function? No, it is not. 4 ruined it. 4 goes to 2 y values. A function means every x has exactly one y. So this x of 4 has 2 y's, 0 and 1, so that is not a function. All right, so let's try another one. So is the relation a function? So we're going to have 2 ovals. In the left one, we put the domain. I'm going to abbreviate this time. So we have -1, -2, 4, and 8. In order, the smallest one would be -2, then -1, then 4, then 8. In the right one, we put our range, our y's. So our y's this time are 1, 2, -5, and -2. So in order, smallest would be -5, -2, 1, and 2. We then match them up. So -1 goes to 1. -1 to 1 is the first point. -2 to 2. -2 to 2. 4 to -5. 4 to -5. 8 to -2. 8 to -2. So then I'll look at it, determine, is this a function? Well, I look, -2 has 1, -1 has 1, 4 has 1, 8 has 1. So every x value just has one y. So yes, this is a function. X has exactly one y is a function. Another way to tell if something is a function, the vertical line test, used to analyze a graph in order to determine if a relation is a function. If any vertical line passes through more than one point of the graph, the relation is not a function. So here's a vertical line right here, right? This represents an x value. Like here, x is 1, x is 2, x is 3, x is 4. So when you have a vertical line, the x value is always the same. The y value keeps changing. So as I go across this v here, which is an absolute value function, the vertical line is always only touching once. So that means whatever the x value is, it only has one y value. So this is a function here. Yes. Whereas if I take that vertical line over here, if I draw a vertical line just like right there, I can see that vertical line touches twice, all right? So if I draw a vertical line, I don't know, I'll just put this one right here, you can see that that vertical line touches here and it touches here. So that means whatever this x value is, it has two y values. So that is a no. If at any place your vertical line touches more than once, it is a no. So here, as you take the vertical line, it's always touching once, 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 once. It's always once. This is called a parabola, is what that U shape is. Always touching once everywhere it goes. So that, yes, is a function. Take our vertical line over to the next one. So we can see, does it ever touch more than one dot? There it's good, there it's good, there it's good, there it's good, there it is not, right? It only takes one place to ruin it. So since this vertical line touches twice, that is not a function. That one is a no. So the vertical line test is another way to tell if a relation is a function. If it ever touches more than once, then it is not a function. If it is always touching one time, then it is a function. All right, so next we're going to look at something called function notation, right? It looks like this. It's like an F with X in the parentheses. We read this F of X, right? F of X. It is just a way to keep track of what X value you are plugging in. This is not F times X, right? These parentheses are not representing multiplication. This is F of X. It keeps track of what you're plugging in. So here we have F of X equals 2X plus 7. Calculate F of 3. So what that means is F of 3 means I'm going to substitute 3 in for X. So I do 2 times X is 3 and then plus 7. So then I'd simplify like always. I'd multiply first. So F of 3 equals 2 times 3 is 6. So then 6 plus 7 is 13. So F of 3 equals 13. So this is a nice way as questions get longer, as they will through the rest of your math classes, to keep track of what you plug in. Because as the questions get longer, by the time you get to the end, you can't even remember what you plugged in at the beginning. So this is saying when I plug in 3, so when X is 3, what I get out, Y is 13. So it's called function notation. It's a way to keep track of what you are plugging into a problem. So here, F of 3 is 13. This one, we have F of 3 equals negative 3x plus 2. What is F of 5? Well, that means we want to plug in 5 to this question. So F of 5 equals negative 3 times x is 5 plus 2. So we're figuring out what we get when we plug in 5. So F of 5 equals negative 3 times 5 is negative 15 plus 2 is negative 13. So F of 5 equals negative 13. Right? So function notation is then an easy way to see, oh, when I plug in 5, what I get out is negative 13. So function notation, F of X, right? You read this, F of X is a way to keep track of what you are substituting into your question. All right, so last topic, finding the range of a function. So the domain is the x's. So the domain of F of X equals negative 2x plus 3 is 1, 2, 3, 4. What is the range? All right, so this is saying I'm going to come up with the range. So the list of y's that are being used. So the first thing I'd want to do is plug 1 into the function. So when I do F of 1, I'm doing negative 2, right, times 1 plus 3. Well, negative 2 times 1 is negative 2 plus 3 is 1. So F of 1 is 1, meaning when I plug in 1, I get out 1. So the first number there is going to be 1. So next it's just saying, it's like this is a list of the x's I want to plug in. So next I want to plug in 2. So when I do F of 2, I'm plugging that into my function. So I have negative 2 times 2 plus 3. Well, negative 2 times 2 is negative 4, plus 3 is negative 1. So when I plug in 2, I get negative 1. And now I realize I should have waited to start to make this because it's not going to be in order. So now I'd want to plug in 3 as my next one. So when x is 3, what is y? Well, F of 3, I would do, I'm plugging in 3, so negative 2 times 3 plus 3. Well, negative 2 times 3 is negative 6. Negative 6 plus 3 is negative 3. Last one, I'm going to plug in 4. So it's saying when x is 4, what is y? So f of 4 would give me negative 2 times 4 plus 3. Well, negative 2 times 4 is negative 8, plus 3 is negative 5. So when I plug in 4, f of 4, I get negative 5. So then here's a list of all of my y values, right? When I plug in 1, I get 1. When I plug in 2, I get negative 1. When I plug in 3, I get negative 3. When I plug in 4, I get negative 5. So now my range, so the domain is the x is being used. My range, typically written in order, I get negative 5. I get negative 3. I get a y of negative 1 and 1. So when the domain is 1, 2, 3, 4, the x is going in. The range, the y is coming out, is negative 5, negative 3, negative 1, 1. And that's the end of chapter 4.